my lovely viewers, and welcome to another edition of our Math Marathon class. Like I used to say, our main purpose here is not to bring questions and solve. Maybe you should go and cram the questions and prepare for exams. That is not what we are here for. We want to teach you mathematics. We want to make sure you understand before we now go into solving questions. Just consider this platform as a class after your physical class, where you go to get clarified on certain topics we are taught in school. So today we are looking into sets. And of course, sets to some people is simple, to others is hard. But both those that find it easy and those that it is difficult for, we are all going to be clarified from this class. And trust me. So let's start. Sets is the topic. Now, a set is a collection of objects which are called elements or members that are classed together. Some people would say it's a collection of well-defined objects. Whichever one, they're all correct. Now, the elements of a set may have something in common. Example, set of mathematical instruments that contains set, squares, protractor, ruler, divider, compass, and the rest of them. And then set of vowels in the English alphabet, that is A, E, I, O, U. Notice that these ones, they have something in common. Now, set forms. A set can be in tabular or builder form. Now, in tabular form, when the elements or members are listed, that means the set is in tabular form. Example, they say that A is a set of 1, 2, 3. And they say P is a set containing 4 and 7. Now, the builder form. This is when the elements are not listed, but with the property to which they can be determined. This time around, they do not list the elements, but with the property that they state, with the condition they state, you'll be able to identify the elements. Example, A is equal to the set of even numbers. Notice that from the set of even numbers, you've already known the members of set A. So A now equal to 2, 4, 6, 8, 10, etc., etc. Number 2 says B is the set of prime numbers. If you know prime numbers, you can be able to identify sets in B. So B is equal to now 2, 3, 5, 7, 11, 17, and then the rest of them. And then Q can also be stated in this way. Q equal to a set. Q is a set containing numbers between -3 and 4. Thus, -3 and 4 are not included. This is -3 is less than x, which is less than 4. When we start inequalities, you know the difference between less than and less than or equal to. Thus, Q is equal to -2, -1, 0, 1, 2, 3. Notice that 4 and 3 are not included in the members. Or it can be y, like y equal to the set of numbers from -3 to 4. This time around, -3 and 4 are included. So y equal to -3, -2, -1, 0, 1, 2, 3, and 4. Now, number 5 says P is equal to the set of x such that x is odd numbers. This symbol here, that bomb is such that it can also be seen in this way, that P is equal to the set of x such that x is odd numbers. So this or this stand for such that. Now we have set types, properties, and notations. The first one is universal sets. And of course, all sets are part of a bigger set called the universal set. It is denoted with capital U or this Greek letter that is called psi. This is the symbol, but the common symbol is capital U. It's used to denote the universal set. Now, complement. A set can be regarded as a complement of another set if it contains elements that are not in the given set. Now, for instance, if we have the universal set to be 1, 2, 3, 4, 5, that's the element of the universal set. And then we have another set, which is a subset of the universal set as 1, 3, 7. Now, A prime or A complement, which is the complement of set A, is noted with A prime or A complement, or the universal set minus A. They are the members of the universal set that are not in set A. That is what we call that. Those are the what we call the A prime or A complement, and it is 2 and 5. If you shake, 2 and 5 is in the universal set, but they are not in set A. So they are A complement. This is they are A complement. That means sets that are in universal set but are not in set A. Now we have intersection of sets. This is formed when two or more sets have a common element. So they have common elements, because it mustn't be one. This is formed when two or more sets. This is formed when two or more sets have common elements. Example, set A has elements like 1, 3, 6, 7. And then set B has 2, 3, 4, 7 as the elements. Now, A intersection B is the symbol for intersection. A intersection B are those elements that are common. That means elements that are in this one and are also in this one. That is what they call A intersection B. And if you check, 3 is here, 3 is here, and then 7 is here, 7 is here. There is no other element that is here and here. So 3 and 7 are the intersection of A and B. So another one is union of sets. The union of sets is formed when the elements in the set can be arranged in a definite order without repetition. That means union of sets is just like the combination of elements that are in two different sets, but making sure that there is no repetition. For instance, if set P equals 1, 4, 5, and then set Q equals 1, 2, 3, 5. Now, P union Q is equal to 1, 2, 3, 4, 5. Now, notice something. This one has 1. Remember, we're not talking about complement. We are talking of union. That means joining the sets, the elements that are in two different sets together. Now, if you notice, this is 1, this is 1. We would have said 1, like 1 and another 1. That means 1 is twice, because element is the element here and the 1 is here. They are now 2, 1. But it says without repetition. So you don't repeat any one. So 1, this is here. Then 2 is in this one. 3 is in this one. 4 in this one. And 5 also is in both of them, but we only took 1. So that is union of sets. Now another one is equal sets. Then sets can be equal if they have the same basic elements, irrespective of the order or number of such elements. We say two sets are equal. That means they have the same elements, but it doesn't matter how the elements are placed or the number of such elements in any of them. For instance, we have A. A has 1, 2, 3 as its element, and B has 2, 1, 2, 3, 1, 3. Now they say that A is equal to B. Why? Because from the definition they said, regardless of the number of or order, where is it? Irrespective of the order. Notice the way this one is placed, 2, 1, like, or number of such elements. If you look at all these things, you notice that Elements that are here are just 1, 2, and 3, but most of them, all of them are 2, 2, and they are placed in different orders. But this one is placed in ascending order, 1, 2, 3. But this one is placed in a different order altogether, and it contains two of such elements. So B is still equal, A is still equal to B because it's the same elements that are here that are here. Now another one is empty or null set. Of course, from from the name, empty. This is a set that contains no element at all. It is denoted with this. That means this curly bracket that is empty, or this symbol circle with mark on it. Then example of elements that are sets that are empty. We can say sets of people with 2 heads. Of course, you know it is an empty set. There's no human being that has 2 heads. Now another one is subset. Now a set that contains elements that are part of a bigger set is called a subset of another set. Example, a class of students is a subset of the students in a school. Of course, you know a class in a school is just subset of the whole students. Now it can be a proper or improper subset. Of course, now it is a proper subset if it is not empty one. It is a proper subset if it is not empty one. It is contained in a bigger set too, but it is not equal to that bigger set. That is B. We have set A as a bigger set, and then B can be considered a proper subset of A if, first of all, B is not empty. Secondly, B is contained in A. That means elements in B are contained in elements in A, and B is not equal to A. That means everything that is in A are not all in B. That is when we say that B is a proper subset of A. Then another one is it is improper. That means it is an improper subset if it is empty. It's either it is empty or it is contained, okay, or it contains all the elements in a bigger set. B is an improper subset of A if it's either B is empty. That's when we consider it as improper, or B is contained in A, but as B is contained in A and B is equal to A. That means all the elements in A are in B. That's when we say that B is an improper subset of A. Another one is a superset. And a superset is a set that contains another set. For instance, we said a subset is a set that is a part of a bigger set. Now, a superset is a set that contains another set. Example, if B is a subset of A, then A is a superset of B. That is, if B is contained in A, then A contains B. If B is contained in A, this symbol stands for is contained, while this one stands for contains. That means B is inside A, and then A houses B. That means A contains B. Number 9 says number of subsets. Now, this is the number of possible subsets of a given set. It is calculated as thus. Number of subsets equals 2 to the power of E, where E stands for number of elements in a given set. For instance, we are given that P is equals 1 and 2 as the elements. Now, the number of possible subsets that we can get in P is 2 to the power of 2, where this 2 stands for number of elements. If you count, we have 2 elements, 1 and 2, which is equal to 4. That means, what it means that we can get 4 subsets out of this set. That is, there are 4 possible subsets of set P. And now, power sets, you notice the difference between power set and the number of sets. Now, power set, now this is the set of subsets, just like the list of all those possible subsets. Number of subsets is used to calculate how many possible subsets that you can get out of P. But now the power set now is the list of all those possible subsets. For instance, if P is equal to 1, 2, then number of sets, which is this, is equal to, number of sets P is equal to 2 to the power of 2, which is equal to 4, 2 times 2, 4. Then the power sets of that P now is listing all those subsets of P, which is 1. 1 is a subset of that P. It's just the set of the subsets. Now 2 is also another set in this P. Then 1 and 2, which is the whole set, is also a subset of that P. And then an empty set, because an empty set is a member of all sets. An empty set is a member of any set. An empty set is a subset of all sets. So that is it for now. Of course, we would say that this is more of theory, and of course that is what set is all about. But we are still heading to where we start solving. Don't worry, when we start solving, we will start enjoying all these things, all this theory. Just for you to know all these things, because it will help us. Of course, they will surely do, they will help us. So in our next class, maybe we should start solving 1 or 2, using all these things we've learned from here. So one more thing, subscribe and then follow. We also have other pages. Just make sure you subscribe to our channel on YouTube and then follow our page. Then one more thing, just take it as I think I've said it before, that this is another class after your physical class. We're not coming here to really solve exam questions, because if you do it that way, you just go and cram, and if you don't, mathematics, you don't cram, you understand. So that's why we are starting from the basics. We are treating it from scratch. You have to understand, and then you can go and start solving it yourself, so that even if no one is there, you can do it yourself. So thank you for following us and staying tuned. Thank you. But try to follow. Then subscribe also. God bless you.